Bismillahirrahmanirrahim and Assalamu alaikum and good morning to everyone. How are you, students? I hope you are fine, right? So students, in today's lecture we are going to start a new topic that is known as fission reaction and fusion reaction, and the name of our chapter is nuclear physics. Before this, let me tell you what we have studied in our previous topic. We have been studied the topic is radioisotopes and uses of radioisotopes, that how useful is radioisotopes and in which areas we use it. And we use it in industries, in medical uses, in surgical purposes, for operational purposes, and many more. So students, let's just start a new topic that is known as fission reaction and fusion reaction. First, we are going to study about fission reaction. What is fission reaction? Fission reaction is a reaction in which one neutron or one element is converted into two smaller elements is known as fission reaction. It is a reaction in which heavy nucleus or heavy nuclei split up into two nuclei with the release of amount of energy is known as fission reaction. What is fission reaction? When a heavy nuclei converted into two small nuclei with amount of energy when a neutron is bombarded on it. Now, this process can be produced when sufficient energy is supplied to the target nucleus or target nuclei by bombarding neutron, because the neutron is chargeless particle and they don't experience Coulombic force or repulsion. Thus, the neutron can be penetrate very easily, and this is known as fission reaction. For example, let's just take an example to understand. Let's take a uranium element of 235 and bombard a neutron on it. So when we bombarded a neutron particle on a heavy nucleus of neutron, so due to this, uranium converted into two nuclei. So what we can say that when a neutron enters into the nucleus of uranium, and it is a compound nucleus. So when a neutron is bombarded on a uranium, so a compound nucleus is formed, is known as fission reaction. Now what happened when neutron is bombarded on uranium 235? This uranium 235 is converted into unstable nuclei and it absorbs the neutron particle and converted into uranium 236. Then this 236 element is unstable, and due to this unstable, it converted into two nuclei X and Y with the amount of energy into 3 neutron is known as fission reaction. Now here, what we can see, when neutron is bombarded on uranium 235, this uranium 235 is converted into unstable nuclei of 236, and due to this it converted into 3 neutron and 3 neutron with the amount of energy and two elements X and Y. Now what is this? Now how we can explain it? We can say that during the fission of uranium, 3 neutrons are produced. 3 neutrons are produced. These neutrons are produced further reaction. These neutrons produce further fission in the given mass of fissionable material. This type of reaction is known as fission chain reaction. Okay? What happened in this fission reaction? In this fission chain reaction can be started in nuclear reactor and a control manner. इसको हम control कैसे रख सकते हैं? We will discuss it later. We can control it in a manner by moderators. ठीक है? And it is a self needed, and there is no need of additional energy to keep it going on. There is a self energy, and it is. Now what happens when a neutron bombarded on a uranium particle, it converted into two smaller nuclei. Then these smaller nuclei become unstable and converted into uranium-236 by the absorption of neutron and converted to 236 element. Then this 236 element is unstable and converted into two nuclei X and Y with the amount of energy with the 3 neutron. Now what happened? These 3 neutron is converted or is reacted with another uranium-235, and this uranium-235 is converted into two unstable nuclei again. Each of uranium is converted into nuclei again, and this unstable nuclei then converted into 3 neutron. Same is performed by this uranium atom. This unstable uranium is converted into 2 nuclei with the release of 3 neutron particle in the amount of energy. Same with this. So we can say that the energy is uncontrollable. This is a very, very strong energy, and we can say that the total energy, and this is the chain reaction, it is going on until we perform an uncontrollable thing. So as we can see that in this topic, in this reaction, we have gained maximum 2 milli electron volt energy, and this is really, really high amount of energy. So for example, we have a bomb. So when a neutron is bombarded on a particle, it release amount of energy, और इससे क्या हो जाएगा, हमारा बहुत ज़्यादा नुकसान हो सकता है. ठीक है, that's why it is uncontrollable and we can't control this energy because this energy is too much. हम अगर इस energy को consume करें, so हमारे कौन कौन से काम हो सकते हैं. अगर हम 1 kg यूरेनियम 235 को लेंगे, ठीक है, तो इसकी टोटल एनर्जी कितनी है, 6.7 इंटू 10⁻11 जाउल. ठीक है, तो इसको हम लोग कैसे कंज्यूम कर सकते हैं, इन टर्बाइंस, इन इंजन्स, इन इट इज़ ऑल्सो यूज टू प्रोड्यूस इलेक्ट्रिसिटी, द फ्लो ऑफ वाटर फ्रॉम लोअर area to higher or from higher area to lower. ठीक है, it is useful but it is not easy to consume, but it destroy. But we can consume it if we take a candium particle in front of radiation. If we want to stop that reaction, so we put a candium material in front of this and we can stop the reaction. So what we can say, if we take 1 kg of uranium, it is equal to this. ठीक है, if we consume it, we can do many of our works through this energy, but we can't consume it because we don't have that much resources. So what we can do, if we take a 1 ton coal, ठीक है, and we burn it, so what will we got? The energy is equal to 3.6 into 10⁻10 joule. This is the energy we got when we burn the coal. Now this energy is very less as compared to this energy if we use uranium 1 kg as compared to 1 ton coal. But this is very, very hard to use this, as we do not have that much resources to use uranium 235 kg energy. So to stop this further chain reaction, we can control it in a controllable manner through candium. If we take neutron and destroy a uranium particle or bombard it, convert it into two nuclei, that is known as boron and krypton. The two nuclei that is converted by uranium 236 after being unstable is krypton and boron, and this boron is krypton release amount of energy. And if we put a candium particle in front of this, then the candium particle will absorb these radiations. Then this candium particle is put in front of this energy, so we can stop this reaction, and this is very useful if we consume it. So this is the overall topic about fission reaction. Let's just study or discuss fusion reaction in our next topic.